Okay, so use node voltage method to formulate a set of equations to find VB and VFD. So the problem wants us to find VFB and VFD. Okay, because it's a node voltage method, we have to find essential nodes. This is one essential node. The other essential node is exactly B, node B, and node C. And then just look at here, node A, remember this node A is not an essential node because it has only two connections, and node C is also not an essential node because it has only two connections. So you don't have to write any KCL for A and C. The only KCL that you have to write is for VB and VD, and this reference node also the voltage is 0. So let's start with writing the KCL on VB and VD. So KCL at V of B. So there's three current, three branches. So one of them is VB, this current minus the voltage here divided by 3. But what's the voltage here? It's because we have a voltage source here is 2IY. So that voltage is 2 times IY. So therefore VB minus 2IY divided by 3 is this current. And then the current going down is VB minus 0 divided by 8. VB minus 0 divided by 8 plus. Now this current here is important because there's a voltage source here. And this current is actually the same as this current. So if you look at the potential difference here divided by 2, that would be the current. So we can say it is V of C minus VD divided by 2. VC minus VD divided by 2. That's this current. And the whole thing, because that's KCL here, the whole thing is equal to 0. So we have 3 branches, we have 3 equations, okay? But V of C and V of B, as you see, there's a voltage source between them, so they're related. So basically, you can say, you look at this 10 volt, V of C minus V of B is equal to 10 volts, right? For this voltage source, VC minus VB equal to 10 volt. Therefore, here, instead of V of C, so in other words, V of C is VB plus 10. And you can just replace it here, okay? You could also do that in your, let's say, head by just saying that, okay, I have V of B, and then there's a voltage source here, 10 volts, so therefore this node is VB plus 10. So just to do one shortcut and just remove one equation. So you could, from the beginning, because you see a voltage source here, and it's VB plus VD, and then when you wanted to write this current here, you can easily say this voltage minus VD divided by 2. You could also do that. So basically, you can just skip one equation, but it's up to you. That's fine. So let's replace this V of C as VB plus 10 here. Also, we have IY. You have to remember that. We have a dependent value here. IY, what is IY? IY is the same current here. So it's this point, which is now I know VB plus 10 minus V of D divided by 2. Okay. So I can replace also IY with that and just simplify the equations. So let's do that. So basically this equation here, VB minus 2 times YI gives me VB plus 10 minus VB. That's 2IY divided by 3 plus VB over 8 plus V of C, which is VB plus 10 minus V of D divided by 2 equal to 0. Okay, so we can do some simplification. There's a VB here, a negative VB there. They cancel each other. So the numerator here becomes with a negative VB cancel. There's a minus 10, and then there's a negative time negative VD minus 10. Okay. And to get rid of the fractions, let's multiply the whole thing by 24. So therefore I get 24 times this. First term is 8. 8 times VD minus 10 plus 24 times this becomes 3 VD plus 24 times the third term, 12 times VB plus 10 minus V of D equal to 0. So just arrange that. VB times, we have a 3 here, we have a 12 here, gives me 15. For VD, I have 8, and I have a negative 12. 8 minus 12 is negative 4, equal to negative 80, 120. 120 minus 80 is 40. When I have to take it to the other side, okay, very good. So this is a simplified version of the equation for the KCL at node V of P. Okay, very good. Now let's do the KCL at node D, V of D. So here, V of D. So KCL at V of D. We have VD minus V of C, which already we know is VB plus 10. So V of D minus VB plus 10 divided by 2 plus the current which is going down. This is 0.4 V of X plus VD minus 0 divided by 5 equals 0. Again, what is V of X? V of X is, we look at here, V of X, look at the direction, 0 minus V of B. So V of X is 0 minus V. Okay. So therefore, instead of V of X here, I just replace it by minus VB. And you have an equation again for VB and VD. So let me extend my page here. Okay. So on this equation, we have, let me also multiply everything by 10, so to get rid of the fractions. So times 10. So we get 10 times that 10 divided by 2, 5. VD minus 5 times VD plus 10. And then 10 times 4, which is 4, but there's minus VB, so minus 4 VB plus 10 times that, so 2 VD equal to 0. So negative 5 and negative 4, negative 9 VD plus VD times 5 and 2, which is 7, V of t equals to minus 50 here. Take it to the other side. And this is exactly our second equation. As you see, it has only BB and BT. So we have to solve it, but here the question says just arrange your equations in a matrix format. Okay, so let's do that. So again, our equations are these. Okay, so in a matrix format. Our unknowns are VB and VD. First equation, 15 VB minus 4 V of t equals to negative 40. And then second equation, minus 9 V of t plus 7 V of t equal to 15. So this is the equation in the matrix format. And after that, you can give it to the calculator and compute it. But here we can stop here just to arrange the equations in a matrix format.